ESA's plan to reach zero space debris calls for global collaboration, of course. The space debris problem won't solve itself. We've been kicking the can down the road for years as we continue launching more rockets and payloads into space. In the last couple of years, organizations, especially the European Space Agency ESA, have begun to address the problem more seriously. And now they're asking this question: what will it take to reach zero space debris? At first glance, it may seem unreal, maybe naive. There are billions of pieces of space junk orbiting Earth, and more than 25,000 of those pieces are larger than 10 centimeters. Though small, these pieces are traveling fast and can cause significant damage when impacting satellites or space stations. What will it take to get rid of all this debris? The ESA has released a zero debris technical booklet to elucidate the challenge to a zero debris future, and propose solutions to get there. The booklet's development follows the signaling of the Zero Debris Charter by members of the zero debris community. Despite several initiatives for space debris mitigation in recent years and modest improvements in public awareness, there is generally consensus that more ambitious actions are urgently needed from all space stakeholders to prevent, mitigate, and remediate debris, the report says. The report points out that the guidelines for the long-term sustainability of outer space activities of the United Nations Committee on the Peaceful Uses of Outer Space outlines how access to space is hindered by the debris. The booklet defines zero debris targets and presents technical needs, solutions, and key enablers that can help organizations achieve them. The obvious first step is to cease creating more debris, of course. It begins with avoiding the unintentional release of debris. Exposure to the space environment can degrade materials during missions and beyond their end date, and unintentional impacts can also, of course, release debris. And the booklet promotes the development of multi-layer insulation and coating technologies, preventing long-term degradation of material, and similar developments for materials that can resist impacts. Improving monitoring, simulations, and testing can help us get there. The booklet also points out the need for different propulsion technologies. Some propulsion technologies release enormous quantities of small particles. The booklet promotes the development of alternate propulsion systems based on things like electromagnetic tethers, momentum transfer tethers, and drag or solar radiation pressure augmentation devices. The booklet also points out to how improved space traffic surveillance and coordination, STC, can help solve the problem. Improved STC will help prevent collisions and reduce the occurrence of unnecessary collision avoidance maneuvers, the booklet states. That will require a technical solution, but different space agencies will also have to share information, which some will be more reluctant to do than others. The technical booklet explains standardized guidelines that will need to be developed and adopted for this to happen. For existing debris, removal is the only solution, of course. For space objects which fail to deorbit themselves for whatever reason, external means can be used to remove these objects from orbit. That begins with assessing defunct satellites to determine the best way to deorbit them. Are they at risk of breaking up due to deorbiting methods? Once assessed, we need to develop reliable and configurable methods to remove them. And that means a technological approach will be needed, as will communication between different spacefaring nations. The booklet states that it will require the development of interoperable interfaces and requirements that facilitate removal for different types and sizes of objects. For example, large and small spacecraft, launcher stages and elements, constellation spacecraft adapted for different orbital regions, for different disposal strategies, controlled, uncontrolled reentry, orbital transfer to graveyard orbit, and with easy adoption in mind, the booklet explains. Deorbiting systems could be as simple as deployable solar sails like the experimental Canadian Advanced Nanospace Experiment 7. It was launched in 2016 and achieved a decay rate of 20 kilometers per year. And while the CANX 7 and other similar systems are passive, they're also designed for active debris removal, ADR. One ADR system is ClearSpace 1. It will demonstrate technologies for rendezvousing, capturing, and deorbiting the end-of-life satellite called Proba-1. After capture, both ClearSpace and Proba-1 will plummet into Earth's atmosphere and be destroyed. Treating and avoiding the risk of collisions between satellites and other objects in space is also part of the booklet. The increasing number of debris and the risks associated with collisions in orbit lead to an ever-increasing need for operators to carry out collision avoidance maneuvers. This can be partially addressed during the design phase, but inevitably requires coordination. And again, the booklet calls for more cooperation between agencies. The effort needs a standardized set of guidelines for collision assessments and methods to integrate collision risk assessments from multiple providers. When it comes to technology, collision avoidance and prediction will also benefit from the development of machine learning algorithms, the development and uptake of optical and radio tracking aids, and the longer list of additional developments. While technology needed to address the space debris problem has not been thoroughly developed yet, there's little doubt that it will be. However, the needed technologies may not be the biggest obstacle to solving the space debris problem. The critical part is cooperation. Without cooperation, the problem will never be fully solved. But cooperation can be in short supply. Our species is at least partly defined by our internecine squabbling and the tragedy of commons. Different nations have different ideologies, politics, and leaderships. And what's worse, some nations are actively creating more debris. In 2007, China conducted an anti-satellite missile test that destroyed a defunct satellite and created a massive amount of debris. In 2017, Russia did the same. India conducted a similar test in 2019, though they claimed that it was such a low altitude that the debris would quickly burn up in Earth's atmosphere. However, the U.S. Strategic Command said the debris remained in space longer than India claimed. It doesn't seem likely that the planet's nations and space agencies will be cooperating at any time soon. But just as with climate change and a host of other problems, we can only solve the space debris problem through cooperation. This is from Universe Today, Even Go on Science Alert. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.